the value of the function at x is equal to a, we are getting this. Left hand continuous as well as right hand continuous must be exist. Find first the left hand limit as well as the right hand limit. Hello everyone, welcome back to LN Overseas. Let's continue our special series. In this series, we will cover 45 important topics in 45 days. And the topic distributions are like 15 in physics, 15 in chemistry, and 15 in maths. I'm going to cover this math section here. So let's start for our today's topic. Our today's topic is how to check continuity, which is very important one. You will definitely get one question in your upcoming JEE Mains exam, right? So here we are going to check how we can check the discontinuity or the continuity in a particular individual function. So you know the 70% work already we have done in the chapter limit. Remaining 10% we need to do here. So here what we need to check, understand. A function f of x be a continuous at a particular individual point. If their limit exists, so that's why the existence of the limit we already have done in the chapter limit. When it will exist, so in that case your left hand limit equal to right hand limit must be. Further, in this symbolically you can say the continuous at x is equal to a if and only if the limit at particular individual function left hand limit, this is your left hand limit like a minus h, so it is equal to right hand limit a plus h at the value of the function particular point. If they all are same and giving us a finite quantity, not infinite, then in that case we can say yes, they are continuous at this particular point, that is in this case x is equal to a. So right now you can say more easiest way like left hand limits are equal to right hand limit, it is equal to function value at that point. If they are giving us the finite value, so that means they are continuous. This is very easy, right? And yes, to be very honest, this is very easy. If you understood the concept, you can easily do some previous year question, and we will do in our today's session here, right? So now one more thing, if continuity of a function must be discussed only at a points which are in the domain of the function. The point it should be in the domain. We cannot pick from anywhere, right? Important thing, one more sentence, at x is equal to a, if you want to check if it is an isolated point, then in that case your function f of x we always consider to be continuous at x is equal to a, right? So in the summary, now we can conclude the finally we need to check what? For the continuity we need to check your left hand limit, if it is equal to right hand limit, if it is equal to f of a and the finite value, all will gives us the finite value, then in that case we can say your function is continuous at x is equal to a, in a very short and sweet language. Fine. Okay, so further I have some picture also. With the help of this you can check, you can visualize what is continuity, right? And how we can check. See, the graphical way is one of the way by which you can also check is the function is continuous or not. So here at x is equal to a, I am just going to pick the point, and in this graph you can see at x is equal to a we are getting like this graph, left hand limit, right hand limit will definitely exist here, and this is continuous. Why? Because you know the one and only one sentence is more than enough if you want to check with the help of the graph, that is if without lifting the pen you are able to make your curve, that means your curve or your function will definitely continuous at which particular point. Getting my point? So here one more graph I have at the same point x is equal to a, I am getting the value of this. Here the value of the function at x is equal to a, we are getting this, as well as the left hand limit will be equal to this, but the right hand limit will be, no, it is not equal to. So right hand limit not will be same as f of a or left hand limit. So then in that case this picture is for the function is not continuous, and whether is this picture will show us the function is continuous. I hope you are getting my point. So the simple thing that you need to understand, that is if you are able to make the diagram, then you just need to check if we are able to make the diagram without lifting the pen, that function will be definitely continuous. If it is not, so it is not continuous. Simple thing. But somewhat I can understand this is not possible to draw the diagram for each and every cases. So then in that case, you just need to check f of a is equal to left hand limit is equal to right hand limit, that's it. Then and only they are continuous. Simple and short concept. So one more thing that we need to check, that is the continuity in a particular interval. How we can check, sir? It is also easy, not a big task. A function f of x is your continuous in open interval. I am just going to talk about first. Then in that case, it will be continuous, must be continuous at each and every point for a comma b. If, for example, if your function is continuous for 2 comma 6 in the open interval, then in that case it must be continuous for 3 as well as 4 as well as 5. Getting my point? Each and every point. A function f of x said to be the continuous in a closed interval. Now I am going to consider the close, right? So again same thing you can pick, and now this time you can pick like 2 comma 6 is there. Again 2 comma 6 for there, for an example. Then in that case, first, if your f of x is continuous in the open interval, a comma b must be, and f of x is a right continuous or right hand limit. How? Right hand limit will be equal to f of a will be the finite value. So right hand limit will be equal to function value at this particular point, for which you want to check within this interval, right? As well as your f of x is left continuous, for example x, left hand limit, this is the indication of left hand limit, f of b is equal to finite, right? So this is more than enough data. In the open interval, how we can check? In the open interval, your function must be continuous for each and every point between their particular individual interval, right? As well as if your function is continuous, you want to check in the closed interval, then in that case each and every point again in the open interval as well as must be continuous in the open interval, as well as left hand limit and the right hand limit, left hand continuous as well as right hand continuous must be exist. Then and only we can say they are continuous, right? So now we have a question from the previous year and we can apply easily, we can do the question, right? So the first question for today is, let the function is this, we have v a continuous at x is equal to 0. This function is continuous at x is equal to 0. It is given that, and we need to find the value of alpha. This is from 2022 July attempt, right? So here what we can do, it is given that this function is continuous at x is equal to 0. So we can proceed easily at x is equal to 0. That means at x is equal to 0. That means your left hand limit, your right hand limit as well as function value at 0 must be same, because it is given that they are continuous. So right now I am just going to pick the point, right hand limit and f of 0. F of 0, it is given that f of 0 you will get 10. So I will pick f of 0, that is 10 according to the question data. Similarly, the right hand limit or left hand limit, anything you can pick. Right hand limit I am going to consider here. Limit x tending to 0 plus right hand limit. I will definitely pick the function that is log 1 plus 5x minus log 1 plus alpha x, and in the denominator I have x. Let's cross check. Log 1 plus 5x, log 1 plus alpha x, and in the denominator we have x. Now let's proceed our concept and we have to follow here. Simple. Limit, we have done such kind of the work. Limit h tending to 0, I can say, right, how much log, here 1 plus 5x, instead of x I will definitely say 0 plus h. So I can write 1 plus 5h only. Similarly here log 1 plus alpha into h, and in the denominator we have h. Now what we need to do, I am getting the point if I can arrange the data in terms of the standard limit, that is log 1 plus something upon something minus log 1 plus something upon something, then I can easily find the value. Are you getting my point? And yes, it is. How? Simple. Log 1 plus 5h, I'm just going to write this by this upon this and this upon this, minus. Here also limit, again you can distribute for both h tending to 0, log 1 plus alpha into h, and in the denominator you have upon h, and here also limit h tending to 0. Now here what we need, we have a need that is phi. So we can multiply here phi and we have to divide with the phi also. Here we have a need of alpha, so we can multiply with the alpha, but we have to divide with the alpha as well. Now here you can see, you can observe. So here you can observe the value of this function we have 1, as well as the value of this function we have 1, right? So right now we are getting the answer from this, that is phi, and this is alpha only. Now this is the answer we are getting for right hand limit, and according to question data it is continuous. So we can proudly say your right hand limit must be same as left hand limit, or as well as function value at particular point, that is 0. So we can use phi minus alpha as the value of right hand limit, and the value of the function we have tan, so you can easily put here, that is tan. Now you will get the alpha, that is phi minus tan, you will get minus phi. So alpha we are getting minus phi is the final answer. Quite easy question, right? So you can see in which option number D it is the correct one. Now let's continue. We have one more question on the basis of same concept, and trust me, that was also easy. If you felt comfortable with the previous one, you can easily do this question also. See, we have what? If the function f of x we have like this, right? For x is equal to pi by 2, you will get mu value. For x between of 0 to pi by 2, you will get this value. From x pi by 2 to pi, you will get this value, right? This is a continuous again, as well as at x is equal to pi by 2. This is important data we have, and we need to find the value of this expression. See, still we have to follow up a concept, not a big task, and this is the question from 2023 Jan attempt, right? So here what I want to do, here I just want to find first the left hand limit as well as the right hand limit at x is equal to pi by 2, because it is given that again this function is continuous. So again your left hand limit and the right hand limit as well as function value at pi by 2 must be same. Getting my point? So here I just want to pick one by one, that is left hand limit. I am getting what? Left hand limit when I am going to talk about, so definitely the function will work this for us. So the left hand limit, that means the indication is limit x tending to pi by 2 minus, and the function we have 1 plus mod cos x, and this is whole power, we have lambda, and in the denominator we have mod of cos x. Now again the same thing, pi by 2 minus h, you can proceed. So you will get limit h tending to 0, and here we have 1 plus mod. Here when I am going to pick pi by 2 minus h, again I will get same kind of the function, right? So you can directly proceed like cos 90 minus theta, you will get sin theta, right? So in short, in the numerator also you will get cos pi by 2 minus h, right? So here we will get cos 90 minus theta, that is, sorry, there is pi by 2. So cos 90 minus theta, you can say cos 90 minus theta, it is again the sin theta, so 1 plus sin h, right? As well as here this is like mod of sin h, as well as the limit we have, that is h tending to 0. Now when we are going to put here h is equal to 0, we are getting 1 and there is 0, but sin 0 is 0, so we are getting something upon 0, that is the infinitive. In short, we are getting 1 power infinitive form, and in the limit we know this thing, how to solve your 1 power infinitive. We can solve by taking e raised to f of x minus 1 into g of x. So when we are going to take e raised to f of x minus 1, so 1 will get cancelled, only you will get sin h into a lambda upon sin h. So sin h also will get cancelled, only you will get lambda. So in short, you will get the final one, that is e power lambda is the value of left hand limit. I am repeating again, this is a function we are getting in the form of 1 power infinitive, and in the 1 power infinitive form, how to solve in the limit, we learn this thing, that is f of x e raised to f of x minus 1 into g of x. I am following this thing, e raised to f of x minus 1 into g of x, the shortcut way to get your answer, right? So here 1 plus sin h minus 1, so 1 will get cancelled, only you will get here sin h into g of x, that means lambda upon sin h. Sin h will get cancelled, only you will get lambda. So that's why you will get e raised to lambda only. So this is the value of left hand limit. Now further, again the same thing we have to do for the right hand limit. You know, for the right hand limit, what we will do, again we have to pick the function that is from pi by 2 to pi, that is e raised to cot 6x upon cot 4x. So right hand limit, when we are going to pick limit, again h tending to 0, now this time again I am going to pick. Why? Because here cot 6x instead of x, when I am going to put pi by 2 plus h. So you know, you can say cot 6 pi by 2 plus h, and similarly in the denominator there is cot, and there is also cot. So 4 pi by 2 plus h is there. So now further, when we are going to write and simplify this thing, limit h tending to 0, you will get cot 6, that means 3 pi plus 6h, and here in the denominator also you have cot 2 pi plus 4 into h, you know. Now 3 pi plus 6h, as we all know, you will get cot theta only. Similarly, cot 2 pi plus 4h, again it is in the first quadrant, so you will get again the cot 4h only. Now we need to solve this thing only. So here, as we all know, cot and cot we have, so it's better to rewrite in terms of sine and cos. So I can write cot, that is like cos upon sine. Similarly, this cot you can write cos and upon sine. Now here, if you have learned the limit, you know, here we can arrange something that is in the form of a standard limit. Again we can proceed, and yes it is. That is what you know, sin theta upon theta and sin theta upon theta I want to do here. So that is for which point of view I just want to divide this thing with 6 into h, right? So here if we have divided, so we have to multiply as well as. Similarly here I want to divide with 4h. So here 4h we have divided. So 4h we have to multiply as well as. So this is the thing we have to arrange here. Now you know, here if you are understanding well, so you know the value of this sin theta upon theta for h tending to 0 you will get as a 1. Similarly, sin 4h upon 4h, still we have something like this. So the value of this thing, again we have 1. So the value of this thing, again we have 1, you know. Now the remaining thing I just want to write here, that is again limit h tending to 0, here cos 6h and cos 4h. So here also h will get cancelled, only 4 upon 6 you have. So 4 upon 6 you can write here, right? Now cos 6h and cos 4h, so you can write cos 6h upon cos 4h. Is there any problem while we are going to put h tending to 0 here? We don't have any kind of the problem, you know, because h tending to 0, when we are going to put here you will get 1, here you will get 1. So we are getting 1 upon 1. So what is the problem? No problem, sir. So now the final answer you can conclude from right hand limit, that is 2 upon 3, right? The value of this function we have 1, only the things we have 2 upon 3. So this is the right hand limit we have. Left hand limit we already have done. So it's time to conclude our answer, that is like left hand limit and the right hand limit according to the concept function value at that particular point, that is pi by 2, must be same. So the left hand limit we are getting, and yes, this is the expression we have solved for which e raised to this thing. So the complete thing we have e power, right? So you can write e raised to 2 by 3 finally. So this is the value of right hand limit. Right hand limit we have e raised to 2 upon 3. Left hand limit we already have done, and we got e raised to lambda. And here the value at the function we are getting as a mu. So this is the expression according to the question and our concept we are getting. Now we can easily make the comparison. Here when we are going to do the compare, we are getting the value of lambda, that is 2 upon 3, first thing. Similarly, the value of mu we are getting, that is e power 2 upon 3, second thing. That's all. Now only finally we have to put all our data in our this expression. So we are getting what? 9 lambda plus 6. So 9 times of lambda we have 2 upon 3. Just I am putting the value whatever the data we have. So 9 times of lambda plus 6 times of log base e, and the value of mu, that is e raised to 2 upon 3. Similarly, mu power 6 plus mu, that means e raised to 2 upon 3, and power 6 is this, minus last one we have e raised to 6 lambda, e raised to 6 times of lambda, that is 2 upon 3. So just we need to solve this thing. Here when we are going to do cancellation, we will get 6, similarly 6, and there also we will get 2 upon 3 only with the property of the log. Here you will get e power 4. Similarly here also you will get 3, and then again you will get 4, so e power 4. So that would be cancelled. Only the things we are getting, that is 4 and 6, final one, that is 10. So the final answer of this question is 10. Actually that was your integer based question from last year 2023 in Jan attempt. So that's all from my side on this topic. Don't forget to watch the complete series. Still, if you have any query or any suggestion, feel free to reach out to us through the comment section. So all the best for your upcoming exam. Thank you so much.